Okay, we're back talking about similar shapes, and specifically, we're going to talk about similar triangles today. There are three theorems that you need to learn, and they allow you to show that two triangles are similar without having to do all the different stuff with the sides, where we show all the sides are similar and that kind of stuff. So, we're going to go over those three theorems real quick, do a couple examples with them, and be done. So the first one is angle-angle similarity. And you should remember some of these patterns. If you look up here, we have side, side, side. We have side, angle, side. Okay, these are three patterns that we've talked about before. So when we come across these patterns, they're going to be used to show us that two triangles are similar. So the first one, angle-angle similarity, says that if two angles of one triangle, so this one and this one, are congruent to two angles of another triangle, then the two triangles are similar. So if you just see that two angles are congruent to two other angles in a triangle, that's enough to say they're similar. So if angle A is congruent to angle F and angle B is congruent to angle G, then triangle ABC is similar to triangle FGH. Okay, the next one is side, side, side similarity. And in that one, if you have one, two, three sets of sides that are proportional to each other. So that would be like if this was 4 and this was 2 and this was 3, I'm sorry, this was 6 and this was 3, and then let's say this was 8 and this was 4. So you see how each one of each one of these is half of these. And so they all have that same proportion. So when that happens, triangle JKL would be similar to triangle MPQ. So it's a lot easier than having to do all the stuff with the angles and all the different sides like we did before. If you see that that's there, then they're similar triangles. The last one is side angle side similarity. So if we see two sides that are proportional and the angle between them is congruent, then that means those two triangles are similar. So let's say that this is 3 and this is 6 and this is 2 and this is 4. So 3 and 6, 2 and 4, that's the same ratio, so those are proportional. These two angles are congruent. So triangle RST would be similar to triangle XYZ because of the side angle side similarity. So you're going to have to look at pictures and say if one of these exists. So quick example, determine whether the triangles are similar. If so, write a similarity statement. All right, so we have 57 and 48, and we look over here and we have a 57 and 75. Well, that means the two 57s are congruent. But this 48, we don't know because 48 and 75 are not congruent. But if you add these two together, 48 and 57, that adds up to 105. And then if you add this 75 to it, that adds up to 180. So all three of these add up to 180, so that means this must be 75 and this must be 48. So in that case, we have two angles that are the same. We actually have three, but we only needed two. And so we have determine whether the triangles are similar. And I'm going to say yes, they have AA similarity. And I have to write a similarity statement. So triangle JKL, remember I can pick any order I want, is similar to, but now I cannot pick any order I want. So J was the 48, so that matches up to O. K was the 75, matches up to P, and L was the 57, matches up to M. Has to go in that order. All right, come over here to example B. So right away I see that I have two angles here that are congruent. So if I could show that my sides are proportional to each other, I'd be good to go. And see right here, 10 and 20 is 1/2. and then 11 and 22 is also 1/2. So my side lengths are proportional. The angle between them is congruent. So yes, these are similar, and they have side angle side similarity. And my similarity statement says that triangle TWZ, remember any order I want, is similar to, now I got to be specific. So TW is the one that has the 10. So that's going to have to match up to the 20. So YW and then X. So there's my similarity statement. All right, come down here. We've got a little different picture. This is two triangles, but they're kind of squeezed into one triangle. But that's okay. So if we notice, this big triangle is 12. This part is 15, right? So our big triangle is 12 on this side, and the little triangle on top of it is 8. So 12 over 8, divide both these by 4, and we get 3 over 2. Now I'm going to do 15 over 10, divide them both by 5, and I get 3 over 2. So my sides are proportional. The angle between them is congruent because it's the same angle in both triangles. So yes, and this is also side angle side similarity. So my congruent statement will say triangle CAB is similar to triangle EAF. All right, last one of these. I have 3 sides but no angles. So I'm going to compare all the sides and see what I get. So I'm going to start with the smallest one and use the smallest one here. So 8 over 6 is 4 over 3. And then I'm going to use the next smallest one. 12 over 9, take a 3 out, 4 over 3. And now I'm going to use the last one. So 16 over 12, take a 4 out, 4 over 3. So all 3 sides are proportional. So yes, the 2 triangles are similar, and that side, side, side similarity. And my congruent statement will say triangle LJK, or my similarity statement, sorry. Now LJ is the second to longest side, so that's MQ, and then P. All right, do another quick example. We have 2 triangles, one on top of the other, and sometimes it's easier to think about these pictures by splitting them up. Okay, so we have a big triangle and a small triangle. So our small triangle is 3, Y, and X all the way around it. All right, so that's A, B, and E. And our big triangle goes A, C, D. Well, from A to C is 5, from C to D is 3.5, and from A to D is Y plus 3. So we want to figure out X and Y. So we're going to start with the only thing we do know, and that's the 3 and the 5. So 3 over 5. And I can't reduce that any, so that's our ratio. And we're going to create a proportion with X and 3.5. So X over 3.5. I'm going to cross multiply and get 5X equals 10.5. Divide both sides by 5. And I get X equals 2.1. Okay, well that is BE that I needed to find, so BE is 2.1. But now I still need to find AD, so I need to know what Y is. So I'm going to come over here and use my 3 over 5 again. So 3 over 5 equals Y over Y plus 3. Cross multiply. 5Y equals 3Y plus 9. So 2Y equals 9. Divide by 2. And I get Y equals 4.5. So AD, which is Y plus 3, is going to be 4.5 plus 3, which is going to be 7.5. That's it. Not too bad. All right, last example. Identify the similar triangles. Well, we've got a set of congruent angles right here. And notice I'm using 2 marks because we already have a set down here. They're very hard to see, but they're marked congruent. So these have angle similarity, so they're congruent. The first thing I'm going to do is kind of redraw them. So I have WSR, that has an 8 and an x plus 6. But then I have another triangle, and I'm going to try to draw it oriented the same way. Right? So the R is this one still, V, and T. And you want to get used to being able to draw these things facing the right way, and all of them pointing the same way. So make sure you understand how to do this. So this is 10, and this is 2x plus 6. So if I look at my 2 triangles, I've got 8 over 10, which is 4 over 5. So that's my ratio. And now I'm going to do 4 over 5 equals x plus 6 over 2x plus 6. I'm going to cross multiply and get 5x plus 30 equals 8x plus 24 minus 5x. 30 equals 3x plus 24 minus 24 minus 24. 6 equals 3x. So you should get that x equals 2. Now I know it says find QP and MP, but you can probably do that. You just take 2, plug it in where it goes, and since there's no Q's and P's in this problem anyways, we'll just stop at x equals 2. So there you go. Enjoy the rest of your day.